All right, here we are, the last set of tests for convergence and divergence. We've gone through 4 sections so far. We've learned all these different tests, and now we are on the final 2, ratio and root tests. Now, root test is very specific. It's only going to be used once in a great while. Ratio is something we're going to use a lot as we start getting into future sections. So although we may not use it for determining convergence and divergence the most, I mean, obviously I'm going to go for p-series and geometric and nth term tests and alternating series tests. I'm going to use those as much as I can. But with ratio tests, we're going to use it later on for something else in the course that that really becomes a major thing that we do in chapter 9. So this is kind of the preliminary of getting it down and putting all the tests together. So let's start with ratio tests. There's 3 pieces to ratio tests that you have to understand. The first that our series of a sub n being that formula, is going to converge if you take the limit as n goes to infinity, the absolute value of a sub n plus 1 over a sub n, and that is less than 1. So if you take that limit of a sub n plus 1, we just got done talking about a sub n plus 1 is where we plug n plus 1 into where the n is, so it's the next term, essentially, over the original a sub n. And if you do that limit and do all the canceling stuff out and you get a value that's less than 1, then we know it converges. Now, the flip side of that is if you find out that it's greater than 1, all right, that's going to tell us that it's going to diverge if that limit as n goes to infinity of a sub n plus 1 over a sub n is greater than 1. So if you get a value that's greater than 1, you get infinity, you get 5, anything bigger than 1, it's going to diverge. Now, kind of the kicker that goes with ratio test is that if you get 1, okay? So if you end up getting, let's see here. Blocking my piece that I need here. There we go. All right, if you get 1, if the limit as n gets to infinity of a sub n plus 1 over a sub n is equal to 1, it is inconclusive. It doesn't tell us anything. So in that case, we would actually just have to do something different. All right. Ratio test is inconclusive. All right. I'm going to move this to this side because I feel that, no, there. The video is blocking what I need to do the math. So, all right, so if you get 1 ends up being inconclusive, which tells you you just need to do another test. It's kind of like if you got 0 for nth term for divergence, it doesn't tell us anything. So you got to move on and do something different. All right, so let's take a look at an example here. All right, we have our series as n goes to 0 to infinity of 2 to the nth power over n factorial. And so what happens is you get these series that are really kind of funky looking. There's exponentials, there's factorials involved, there's all this extra stuff that normally we don't have with the other different tests. All right, so let's go ahead and try this out. What we're going to do is the limit as n goes to infinity, absolute value. Just remember, the absolute value really just knocks out that alternating piece if we need to get rid of it. All right, 2 to the n over n factorial. We're going to put n plus 1 in for those n's. So 2 to the n plus 1 over n plus 1 factorial over the original. So 2 to the n over n factorial. We kind of saw something like this with our limit comparison. We had to do that fraction. Well, remember, whenever you do this fraction, it's really just multiplying by the reciprocal. So let's go ahead and rewrite that here. Limit as n goes to infinity, 2 to the n plus 1 over n plus 1 factorial times the reciprocal n factorial over 2 to the n. Well, this is where we got to do some major canceling out. And this is something we did earlier on in this unit and all the simplifying. So we got to think about what ways we can simplify this. So let's talk about 2 to the n plus 1. 2 to the n plus 1 can be broken apart since we have those exponent rules that we talk about. So you got 2 to the n times 2 to the first. Okay, remember when you multiply, we add exponents. And then n plus 1 factorial right underneath there. We can rewrite that as n plus 1 times n factorial. Now, the whole purpose of this is so that we can now start canceling stuff out. We can see we can cancel out the 2 to the n and the n factorial, which leaves us with limit as n goes to infinity of 2 to the first over n plus 1. Well, if you do that limit to infinity, all right, you put infinity in that bottom, we're going to get 0, which is less than 1. So this means it converges by ratio test. All right, so just like that, what we're looking at here is taking that limit to infinity. And again, we got to remember how to do limits to infinity. We've talked about it most of this chapter. All right, bottom's going to be bigger, it's going to go to 0. Top's going to be bigger, it's going to go to infinity, and so forth and so on. All right, so that's one example. A lot of it's just a lot of simplifying, breaking things apart, canceling things out, and then seeing what you get. Let's take a look at another one. All right, our next one, we have a series n equals 0 to infinity. We have 3 to the nth power over n squared, 2 to the n plus 1 power. So again, we got a lot of stuff going on here, but let's go ahead and set this up. We have limit as n goes to infinity. All right, I'm going to go ahead and just multiply by the reciprocal right off the bat. So I'm going to put my n plus 1s in. 3 to the n plus 1 over n plus 1 squared, and 2 to the n plus 1 will actually give us n plus 2 times the reciprocal, so n squared, 2 to the n plus 1, and 3 to the n. Okay. Here I'm going to break everything up just like I did in this last one. So I'm going to do limit as n goes to infinity. Okay. And then we're going to do 3 to the n times 3 to the first. We'll leave the n plus 1 squared, and this will be 2 to the n times 2 to the second times n squared. I'm going to break this apart to 2 to the n times 2 to the first and 3 to the n. But now I can start canceling all my stuff out here. So let's go ahead and take out 3 to the n. That's gone. Let's go ahead and take out 2 to the n. That's gone. And then what we end up seeing here, okay, I have 2 to the first over 2 to the second. Well, that gets rid of one of the 2's. So now if you look at what's left here, we have limit as n goes to infinity. We have a 3 still, we have an n squared, and we have a 2 and an n plus 1 squared. Well, this is where we get to use a little of that rule of insignificance. Let's get rid of that plus 1. So then you just have n squared over n squared. That whole thing cancels out, and this is going to give us 3 over 2, which is greater than 1, which tells us it diverges by ratio test. Okay, so there's an example of converges and an example of diverges. All right, every one of these is very similar to this. You just got to be careful when you plug in that n plus 1 and simplify, only cross out the stuff that crosses out. Okay, so that's ratio test. Like I said, root test is a little bit more specific, but it has actually the same 3 conditions here. Okay, the same kind of 3 pieces that go along with it. Our first piece is that series is going to converge if the limit as n goes to infinity of the nth root of the absolute value of a sub n is less than 1. So root test is all about roots. You're actually taking the nth root, which means it's very specific to something raised to the nth power. And you'll see that in our example. All right. Same as the last one. Our second condition is that series is going to diverge if the limit as n goes to infinity of the nth root of absolute value of a sub n is greater than 1. All right, so same as our ratio test, greater than 1 is going to diverge. And our last case, all right, if that ratio or that root here, that limit as n goes to infinity of the nth root of a sub n is equal to 1, the root test is inconclusive. Again, find another test. So if you get 1, you probably shouldn't use it in the first place. Okay. All right, so again, this is very specific. It has to be raised to the nth power. So here's an example, and if you take a look at this, all right, both of this numerator and denominator, they're raised to some form of the nth power. Even though we may not actually see it up at the top right away, using those exponent rules, we can rewrite this as e squared over n raised to the nth power. All right, because remember, when you raise a power to a power, if you do the top there, 2 times n is going to give us 2n. And the bottom would just be raised to the n. All right, so really you're looking for, there's no like extra pieces of this. The whole thing has to be raised to the nth power in order to do this. Well, if we go ahead and do the limit as n goes to infinity of the nth root of e squared over n to the n power, we see that the root and the nth power cancel, and that's what should happen. You should end up being able to cancel something like this. And then once that cancels, you have limit as n goes to infinity of e squared over n. Well, if you put infinity in for that, you get e squared over infinity, which gives you 0. And so this is less than 1, so it converges by the root test. All right, so it's very specific how we use the root test. It's not going to be one that we see all the time, but keep an eye out for those things raised to nth powers. That's the best time to use this. All right, and guess what? That's the last test. We did it. We got all of our tests for convergence and divergence taught. And now we can put them all together to find a way to remember them. And this is where I teach you to remember parting C's. Parting C's is your mnemonic to remember your different tests. So P stands for P series. A stands for alternating series test. R is for the one that we just learned, ratio root test. T is for telescoping. I feel like I'm on Sesame Street right now. I is for integral. The letter of the day is N. N is for nth term test. G, everyone's favorite, geometric. NC, my least favorite, comparison tests. And we talked about direct and limit comparisons. And those are all of our tests that we've learned for convergence and divergence. And so now you can use any of those tests to figure out if a infinite series is going to converge and diverge. Some of these will show up again as we continue through this chapter, but our upcoming test will cover all of 9.1 through 9.6. And that will have all of this on here, including sequences that we did in 9.1. All right, so practice ratio root test, and we'll put it all together when I return. All right, good luck.